Hi, welcome to Petradot. In our previous lessons, we talked about the Java operators, where we discussed about the arithmetic operators for basic mathematical calculations, the assignment operators for assigning values to variables, where we talked also about the simple assignment and the compound assignment. Then we also learned about the comparison or relational operator, then the logical operators for logical operations. We also discussed ternary or conditional operator, that is a short form of an if statement. And then finally, we also discussed of the instance of operator, which is used to check if an object is an instance of a particular class or interface. So in this lesson, today's lesson, we'll be talking about the bitwise operators. Now, what is the bitwise operators? They are those operators that are used to manipulate the individual bits within a whole number. That is within the integer type of variables, byte, short, and long, right? And we have different type of bitwise operators. I have collected all of them here together so that we can discuss them in detail. And to start from the first, they are called the first one is the bitwise AND operator. The second is the bitwise OR operator. The third, bitwise exclusive OR operator. Then the bitwise complement operator. Then the bitwise left shift operator. And the bitwise right shift operator. So we are going to be discussing them one after the other. So it is very important that you understand how they all work. They are used to manipulate the individual bits in a whole number. Just like I told you earlier in our previous lessons, the computer only understands the machine language, which it is the zeros and the ones. And a single bit is represented by either a 0 or 1. So when you see a 0 or a 1 in the machine language, it means a single bit. So these bitwise operators are used to manipulate these bits. So let's see, how does the bitwise AND operator work? The bitwise AND operator is represented by this single AND sign that you are seeing here. So, and its definition says that if both given bits are 1, then the result will be 1. Else, any other result between the two bits will be 0. Right? So, what does it mean? If you are given two bits, let's say you are given a bit 1 and another bit 1, and they said, and the expression says 1 and 1 as seen here, it means that both sides, as it says, if both given bits are 1, if both the given bits are 1, means that the result of 1 and 1 will be equal to 1. So check here now. Here we are given two bits also, which is 1 and 0. So the two bits here are not 1, meaning 1 and 0 will give us what? 0 instead. And same applies to 0 and 0. It will also give us 0 because it is not 1, because the definition says if both given bits are 1, then the result will be 1. So for example, let's test run it now. Let's say we have let's say we have a number, this number int a equal to, let's say we use something like 7 is equal to 7, and we'll say int b is equal to 5. Yes, it's true, we are defining an integer here. Just like we said, the bitwise operators are used to manipulate the individual bits. So what does it mean? Before the computer will perform any operation for us, it is going to convert it first to the bits. So let's say we wanted to print out something like system.out.print line a and b. So before we run this, let us do some verification of what the results should come out with. We might not be able to start learning how to convert whole numbers to their binary equivalent. So you can probably do some research online and learn that on your own. But the binary value of 7 is 0111, while the binary equivalence of 5 is 0101. So we're interested in these bits that you are seeing here now. So each of these bits is what we're interested in. So now, with what you are seeing here now, what we are going to be expecting is to find the binary digits of this and, because we are trying to check the and sign, and answer says both bits must be 1 for it to be what? 1. Now let's check what the result could be. 0 and 0, both bits are not 1, means we are going to be getting 0 at this point. 1 and 1, both sides are 1, means we are going to be getting what? 1. 1 and 0, both sides are not 1, so we are going to be getting 0 here. 1 and 1, both sides are 1, means we are going to be getting 1. So our value is equal to what? 5. So we are getting our result that is going to be printed should be 5. So let's test run this and see. So run our program. You see it now. We're having 5 as our output. And that is how the AND operator works, the bitwise AND. So with this now, we should be able to find it for other ones, the OR operator. Let's still use the same integers that we have here so that we can do the calculation. So now, let's say we want to print out system.out.println A or B. That is the bitwise OR operator. It is represented with a vertical bar. And what is the definition? It says that if both given bits are 0, then the result will be 0. So it is only 0 when both bits are 0, else the result will be 1. You understand? So, for example, seeing here now, let's say we have 0 or 0. We are going to be getting what? 0 as our result. But if we are having 0 or 1, then our result is 1. And if we are having 1 or 1, our result is what? 1. So let's use here as an example. What should our result be if we should find 7 or 5? That is A or B. If we should do that, the binary digits of 7 is 0111 and that of 5 is 0101. So let's take it one after the other. 0 or 0 is going to give us 0. Why? Because both bits are 0. Then the result will be 0. That is why we're having 0. Now 1 or 1. Since it's not 0, 0, it's going to give us what? 1. We'll pass 1. 1 or 0 should give us 1. And 1 or 1 should give us 1. So now the equivalence of this binary digit is equal to what? 7. You can even see it here already. So it's 7. It's same thing with this. So if we run this program, we should be able to be getting what? 7 as our result. Let me put a comment, a kind of message on this, so I will differentiate each. A or B equal to, let's concatenate the result. So put it in brackets, the same thing. Let's do the same thing here. So I can differentiate each whenever we are printing it on our output. A and B equal to. All right, so let's run it now and see. You can see here now, A and B is giving 5. A or B is giving 7, which is what we got here. All right, and that is about the bitwise OR operator. So now let's go to the bitwise exclusive OR operator. Now what did this one say? This one says if both bits are same, then the result will be 0. If both bits are same, then the result will be 0. Else, the result will be 1. So whether it is 1, 1, it should be equal to 0. The result will give you 0. But if it is 0, 0, it will give you what? 0. The only time it will be 1 is when it is 1, 0 or 0, 1. Right? So, like for example, here you can see 1 exclusive or 1 will give you 0. 0 exclusive or 0 will give you 0. But 1 exclusive or 0 will give you 1. Right? So let's try printing the result. All right, see this now. Let's before we print the result, let's try it on our own end and check the try calculating it manually and see. So now, coming from these two integers here, checking from these two integers, a exclusive or b, 0 exclusive or 0, they are the same. The formula says if both sides are same, then the result is 0, meaning that the first two bits will give us 0. The second two bits 1 or 1 will also give us 0. The third two bits 1 or 0 will give us 1 because they are not same, while the last two bits will give us 0 because they are same. And the equivalence value of this is 2. Right, so this is the binary digits of 2. So let's print this, let's run this program and see what is going to happen. Let's see what the result is saying. We can see this now. We got 2. That is a exclusive or b will give you equal to 2. All right, that is all about the bitwise exclusive or operator. Now we have the bitwise complement operator that is presented to the is similar to character symbol, right? The bitwise complement operator. What does this do? Definition says it adds 1 to a given number and multiply it by -1. So given that you are given a particular number, say 5 or any number at all, then what does it do? It will add 1 to it and multiply it by -1, and that is when you get the result. So given, for example, here we are given 5, so the is similar to 5 will give you 5 plus 1 multiplied by -1, which will give you what? -6. So if we take that we are given a negative number, that means is similar to -9 is equals to -9 plus 1, which is supposed to be giving you what? -8. -8 times -1 will give you what? +8. That is a positive number instead of a negative. So let's test run this and see. System.out.print line. So that is, we are checking for is similar to 5 is equal to similar to 5. So let's see what the result will show us. If we run this program, what are we going to get? Exactly, you can see it, we are getting -6. Oh, we didn't do the manual calculation before. Okay, we did manual calculation. Look at it here. So that is it showing here, right? So the result is -6, meaning that if we try with -9, we should be getting what? 8. Let's copy this and try with -9. Exclusive or is similar to -9 will give us similar to -9. So we should be expecting 8 as a positive number. Exactly, and we are getting it. So let's try a different number entirely. Say is similar to 20. Let's see what the result would be. We should be getting what? According to the formula, +1 times -1, that is -21. So we should be expecting this as our result. Exactly, and we have it here. All right, that is all about the bitwise complement operator. All right, the bitwise left shift operator. What does this one do? It shifts the bits of the first number to the left by the number of the positions stated by the right hand number. That is, for example, you were given two numbers. This is the left hand number and this is the right hand number. And it says 4 left shift 3, right? So we are shifting 4 in 3 positions. That is what it means. But it has a formula. To get the result of this, what the output should be, you do what? Multiply first value by 2 raised to power second value, right? So that is what we have here. 4 times 2 raised to power 3. And that is what will give you 32. So let's run this, let's print out the result and see. System.out.print line, where we'll have 4 left shift, that is double less than sign, left shift 3 will give you this. So we're expecting 32, right? So let's run the program and see. Exactly, I will have it here. So let's try with a different number entirely. A different number, say system.out.print line. Say we are doing 6, or let's reduce a smaller number so that we'll be able to do our calculation well. By well, let's leave it at 3. Let's leave it at 3 anyway. So we'll have this. We are shifting 2 to 3 positions. So what we should be getting is 2 times 2 raised to power 3 is equals to what? 2 raised to power 3 is 8. That means 2 times 8 will be 16. So we'll be expecting 16 as our result. Alright, so let's run this program. Exactly, I will have it here. Alright, so that is all about the bitwise left shift operator. So now the bitwise right shift operator, it says shifts the bits of the first number to the right by the number of positions stated by the second number. So it shifts 8, for example, to the right by 3 times in 3 positions, right? So but the difference between right shift and left shift is that the right shift formula uses multiplication, while this is division. So the formula is same for you to see what the result the computer is meant to return. So 8 divided by 2 raised to power 3. 2 raised to power 3 is already 8, right? So that means 8 divided by 8 will give you equal to 1. So let's run the program and see. System.out.print line. We are doing 8 right shift, that is double greater than right shift 3, right? Is it 3? Okay, it's 3. That means 8 right shift 3. So let's see what it is going to print as our output. So we're expecting 1. Exactly, we're expecting 1 as our output, and we have it here. Alright, and that is all about the bitwise operators. So just like we said, they are used to manipulate the individual bits of a whole number in the computer. So, and that will be the end of the lesson. Don't forget to like and subscribe. Thank you.